Unit 3.1, Representing Relations. Warm up. For the equation y equals x squared plus 3x minus x, complete the table by calculating y for each x value. And of course, as we remember from the past, to get you started, you're going to take the equation y, and so we're looking for our y answers here. And we're simply going to substitute or evaluate is what is often called. So let's take it x squared So here I've written mine out, x squared plus 3x minus x equals y. And it doesn't matter that the y is at the end. I wrote it this way so you can become accustomed, again, to seeing it written in different ways. We took the x value and we simply substituted. One thing I highly encourage you to do is put your substitution in parentheses. So we have negative 2 squared plus 3, and again, we see the same x that goes in parentheses, negative 2, minus the same x, negative 2, and all are in parentheses. Now, let's go ahead and simplify it. And we know negative 2 squared is negative 2 times negative 2, which gives us a positive 4. Plus 3 times negative 2, and we know that gives us a negative 6. We had an option. We could go ahead and put the plus, or we could not have put the plus, and we very simply could have simply put negative 6 instead. Either one works. But if you put plus, this plus right here, if you put it, then put your negative 6 in parentheses. Minus negative 2, and we know a minus and a negative gives us a positive. So that's plus 2. So we have 4 plus 2, since both of these are positives, and that gives us 6. So it takes us here to 6. Again, that's positive 2, positive 4, minus 6. And therefore, this is 0. And because our y value is 0, then this is our x-intercept. This is where our line is going to cross the x-axis. All right, so since we've done this in the past, how about you try and you do the rest? Pause your video. Now, moving on to representing relations. We know that there are relations is a set of ordered pairs. That's a set of ordered pairs, so we've just found right here. This is not an ordered pair because it's by itself. These do not count as pairs because each one must have a y value. We know that domain is our x values. The set of the first number, again, the x value of the ordered pair in a relation. Again, this is our x values, x range. That's the set of the second number, and we know the second number is our y value. So it's all of the y's, very simple. Here we can see our domain. Our domain is negative 2, negative 1, 0, 1, and 2. But we have to find the range. which is y. Our independent variable is the variable in a relation, and it's usually x, with the value that is subject to choice. I'll explain that in a moment. Dependent variable, it's the variable in a relation, usually y, with the values that depend on x. In other words, here we know all of our x values. This is independent. X doesn't need anything to be found. We know what it is. Our y depends on what x is. So once we plug in -1 into this equation, of course, we're going to get something different than 0. And the same goes with 0 and 1 and 2. So that makes y dependent. Dependent. Y is dependent because it is found based upon whatever x gives. With relations, we've learned that there are 4 types of relations. The 4 types are list. You've seen these way back since 6th grade for sure. Your table, and this is a vertical table, whereas this one, it's a horizontal table. Your map, and a graph. And if you will note, all of these, -4, -2, -4, -2, -4, -2, -4, -2, all of these are the same points. They represent the same 0, 2, 0, 2, represent the same point, and you're just seeing all of them written in the 4 different ways. Example 1, it says representation of a relation. Use 2 point, use 20, 0, 4, 3, -5, and -5, -3, -5, and express each relation. Remember, each of these are a relation. You're going to express the relation as a table, 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 a map, map, a graph, graph. You've already been given the list. So you're going to take these same numbers, graph them, use them in the map, and use them in the table. The same as this. Example 2, list the ordered pairs of each relation below. And here is just a reversal. We've already given you the ordered pairs in the table. We've given them to you here in the graph, and we've given them to you here in the map. And you are going to write them here. And when you write them here, you are writing them as a list. So everything should be in parentheses. For each one. Analyzing graphs of relations. The values in the domain correspond to the independent variable in a relation. The independent variable, again, usually x, has a value that is subject to choice. In other words, whatever x wants to be, that's what x is. Of course, that is dependent upon the equation or the situation. In the graph shown, the independent variable is the days. So here we've given you a graph, except this is somewhat called a line graph, a picture graph, a situation graph. And this is your x value. And this is y. Just in case you're a little lost, all that means is that instead of taking all of this You've simply been given just a small portion of that graph. In other words, you don't have this part. So you're only looking at this portion, which is your positive side. This is still X, this is Y. X and Y. So here it tells you that your X is days, and we're talking about driving time. So in reading this one, we can count this. You can add your own days, put your own numbers. We could say one, we could say two, all the way down to 10. And this is how long it's taking us to get to wherever we're going. And of course, this is 0. So the amount of time, whether in one day we drove 10 hours, the next day we could have driven 20. Well, let's look at what's going on though. Here, it shows you how fast or slow you're going. The flat line, that's usually either a stop or a constant speed. In this case, it looks like it's a constant, which means you didn't drive at all during this flat line. And each one of these indicates how fast or slow you drove. This is another stop. So let's go on down to the next graph and let's see if we can read it. All right, so here it says, analyze the following graph. The graph represents the number of text messages sent by Nora throughout the day. Identify your independent and dependent variables of the relation. And what did we say the independent variable usually is? And first of all, let's go to our x. This is x. And what is our independent? It is indeed. It is time. So we know that's what that is. And our dependent, again, we can go to y and see our dependent is text messages sent. So text messages sent, dependent is time. Here it says describe what happens in the graph. So over time, and again, whether you want to call it minutes, hours, you can give it a number if you choose. That's up to you. But in your answer, do not use your numbers. Just talk about the time. So what's happening in this? What's going on? What's happening over the time concerning the text messages? What happened here? And again, you can give these times. Maybe you sent 5 texts within 1 minute. And then you stopped. Didn't send any more text for the next minute. Then what happened? So you're going to describe what happens in the graph. Here it says after an airplane takes off, their altitude increases rapidly. Once it reaches the desired altitude, it continues to fly at that level for a short period of time. Then the airplane's altitude fluctuates slightly due to turbulence. Finally, the altitude decreases quickly as the plane lands. Which graph best represents the situation? First of all, let's find your independent and dependent variables. And it looks like our independent on all of them is x, which is time. And the altitude is y. So let's highlight what's important to us. Here it says our plane takes off. Altitude increases rapidly. Once it reaches the desired altitude, it continues to fly at that level for a short period of time. Then the plane's altitude fluctuates slightly due to turbulence. Finally, the altitude decreases quickly as the plane lands. So let's look at this. So here it says increases rapidly. I know I didn't go over that. So let's talk about rapidly. Here, if we look at this line, or better yet, let's just go with one. No, let's look at this. Let's use this as an example. If we look at the lines here, and let's just use the end, I'll go red, this line right here. This line is steeper than this line. The steeper the line, the faster it is going. The steeper the line, the faster it is going. The more horizontal the line, either the slower it is going or it has stopped. Again, the steeper the line, the faster it is going. So this is going much faster than these text messages being sent. This could be a continue or a stop, since we're talking about days. And this could be a stop, since we're talking about time. Or it could be continued the same number of messages over that amount of time, continued the same speed over those amount of days. So let's look here. In all of them, we have a airplane takes off, increases rapidly. Rapid increase, good, steep. Here, same steep, yes. Up here, it looks like it's kind of slow, yeah? Yeah, kind of slow. So this one, good steep. So we can eliminate C immediately. Let's not even waste our time on it. So C is eliminated. Then it says, once it reaches the desired altitude, it continues to fly at a level for a short period. Okay, it could be it, flying at a level for a short period. Flying at a level for a short period. And we've eliminated C. Flying at a level for a short period. So A, B, and D are still in. Of course, we could just question whether this is really a short period, but in any case, let's go to the next one, which it says, so we did that. The altitude fluctuates slightly. We know fluctuates mean up and down, but it says slightly. Here, there's no fluctuation. Here, there is some fluctuation. So we've eliminated A now. And here, whoa, that's some serious turbulence. So slight fluctuation. So we can eliminate D because that's serious turbulence. And finally, the altitude decreases quickly. And here, decreases. And I know I'm going back to A and D. That's simply to show that they were still in the running for a while. That's how we read this map. Okay, so it took off, flew very calmly till it hit turbulence, a little turbulence, got itself together, then it began to land. All right. Interpreting Sales and Origins. The average number of posts per day on a social media site each year is given in the table. Plot the values on the graph provided, then interpret the meaning of the axes, scale, and origin of the corresponding graph of the data. So here we've been given the year and the average post. So here it talks about the years since 2008. So this would be 2009. 2010, 11, 12, 13, 14, 2015, 16, 17, 2018. That's what that means. Again, this is 2006. I'm sorry, 2009, 2010. So let's go ahead and graph 2008. So here, so what I did here is, we know this is 100, and half of that, therefore, is 50. So I just marked the 50 point, and half of 50 is 25. So we marked our 25 point. So this is about 25 once again. This is about 50. Yeah, it's kind of difficult to write with this. All right, so here we needed 15. So 15 is going to be slightly above that old 12, which is half, a little bit less than half, or the 12.5 of our 25 to 0. So 15 is about here, give or take a centimeter there. We said this is 2009, and at 2009, it was at 20. Might be up a little bit there. And here is 35, 2010. And you graph the rest. And again, you can take each one, remembering they're in increments of 50, really, even though it numbers them by 100. So this is 150, 250, etc. And it says your x-axis represents, and what does it represent? It represents the years since 2008. And what does your y-axis represent? It's the average post per day in millions. Okay. Our scale, your x-axis scale, is scaled by ones, by year. So it's scaled by years, 1 year. No, I'm not writing this because you guys have a tendency of just copying everything. So again, your X scale is in increments of 1 year, 1 year. Maybe I will put that in. Mm. And your y-axis, your average post, it's really in increments of 50 million because of that line. I know they showed the 100, but it's really in increments of 50 million. Your initial value, the point 0.015 represents what? What does 0.15 represent? I'll let you put that in your own words. In other words, what happened in 2008 concerning the number of posts per day on social media? All right, so this is your exit ticket to see if you understood.